Hi everyone, welcome to this video lesson. In this video lesson, you will learn how to transform the graph of quadratic functions. Okay, so I'm going to be pausing the video and writing things down here, and then I'll come back and continue recording. This is so that this video is not too long. Okay, so I'm going to go ahead and get started now. All right, so this a value in front of the parentheses. Okay, notice that this is a quadratic and this is vertex form. So this value of a either stretches the graph or shrinks the graph, and also reflects the graph over the x-axis, depending on whether a is positive or negative. And just like absolute value, if a is more than 1, then it's going to do a vertical stretch. If it's in between 0 and 1, then it's going to be a shrink. Okay, and then also this value of k, it's a vertical transformation, so this either moves the graph up or down depending on if k is positive or negative, or you have a minus or a plus in front of it. And just like with absolute value, whatever is inside of the parentheses means the graph goes left or right. Okay, so plus means left, minus means right, so it's counterintuitive again. So then this helps you determine if the vertex of the graph goes left or right. So it's just like the absolute value. Also, this h value has to do with the value of x at the vertex, so this is h, and k is the value of y at the vertex point. So the vertex has coordinates always in general of h comma k, and the axis of symmetry is the value of x at the vertex, which is x equals h. So the next part, if a is more than 0, then the graph opens up. Okay, which means if a is greater than 0, it means the value of a is positive. So if this is the case, then the graph opens up. Okay, so it opens up, and then this point is called the minimum. So I'm just going to write min for minimum. What happens if a is less than 0, which means the value of a is negative? So if a is negative, then the graph opens down, the parabola opens down, so then the graph looks like this. So this one has a max point at the vertex, so this is the maximum. Okay, and that happens, that's the value of y at the vertex. So this is the introduction. Now let me go over the examples. So for this one, the value of h is -5 in this case, but notice if it's minus, means it's going to go to the right. So then x is 5 and k is -2. So then the vertex is at -5 comma -2. I'm going to plot that point right away. So 1, 2, 3, 4, 5 down, 1, 2, plot a point. From there, if you remember the table from the quadratic function, I'm going to go left 1, up 1, left 2, up 1, 2, 3, 4. I'm taking the square. Right 1, up 1, right 2, up 4. So if you don't know how to do this, watch the video for the parent function of quadratics, and I explained that in detail in that video. So this is the graph. So then the transformations are, the graph goes right 5 and down 2 units. Then the vertex is here, transformation, so we have domain and range. So domain of this graph, this keeps going to -infinity, +infinity. So domain is x such that x is any real number. Again, that's set notation, interval, -infinity to +infinity. The range, the value of k is -2, and from there the graph goes up. So then y such that y is greater than or equal to -2, which again is the value of k. So we have a minimum. In interval, you would say from -2 to +infinity. Okay, so that's for example number 1. For example number 2, the vertex coordinates are -2 and 1. This is plus, so then the graph goes left 2. So from here, go left 1, 2, and then up 1. And now notice, this has a negative in front of it. So if it's positive, in this case we had a positive 1 implied, we have a -1 implied. So this graph, instead of opening up, is going to open down, because again, the value of a is negative, so the graph looks like this. So if I go left 1, down 1, if I go left 2, down 4, so this is 2, 3, 4, plot a point there, right 1, down 1, right 2, down 4, and there's also the y-intercept. Then connect the points, and that's the graph for this function. So transformations R, the graph got reflected over the x-axis because of that negative. Then it went to the left 2 and then up 1. Domain is all real numbers, and the range is y such that y is less than or equal to 1, because from the vertex point, this graph goes down, so there's a max at the vertex. Okay, so let's move on to the next example. Example number 2. Notice that this has a -1, so write 1 and no k value, which means k has to be 0. So then this graph just got translated to the right 1 point, one unit, then left 1 up 1, left 2 up 1, 2, 3, 4, and then do the same on the other side, and you get those points. Then connect them. That's one side, and this is the other. Transformations, there's only one. The graph went to the right 1 unit, and then domain, it's not going to change. It's x such that x is all real numbers, and the range is y such that y is, this opens up, so greater than or equal to 0. So that's all for this example. Okay, let's continue on down to number 3. So for number 3, there is no parentheses, which means you only have x stays at the origin, so 0, but y, the k value is 4. So then the graph goes up 1, 2, 3, 4, and this is the vertex point. From here, left 1 up 1, left 2 up 4. Okay, and let's see, right 1 up 1, right 2 up 4, then connect the points, and this is the graph of that parabola. Transformations, only one, up 4 units, and then domain does not get affected by the transformations. It's all real numbers every single time for quadratics. The range depends on the value of k. So then I'm going to do R here, y such that y is from 4. Okay, from 4 the graph goes up, so greater than or equal to 4, and there you have the domain and range and transformations in the graph of this function. Let's go on to the next example. So for example number 5, we do have a -2 in front of the parentheses, so then the y values are going to be multiplied by a -2. So then this graph just looks just like this one. It's going to be up and down. But the vertex point is where x is 3 and y is 4. So 1, 2, 3, and then up 1, 2, 3, 4, plot a point. Now if I go left 1, I usually, in this case I will go down 1, but I have a 2, so multiply that 1 by -2, so then go down 2. If I go left 2, usually go down 4, but then multiply that 4 by -2, then that gives you, this will be 4, 5, 6, 7, and 8, and plot a point there. Right 1 down 1, right 2 down 8, and then connect the points. And this graph got vertically stretched by a factor of 2. So I'm going to write down the transformations first. So the transformations are reflected over the x-axis, got reflected, and has a vertical stretch by 2. There's that 2, and then went to the right 3, and then up 4. Okay, domain is x such that x is all real numbers, and the range is y such that y is less than or equal to 4, because from 4 this graph opens down. Okay, all right, so the last example, I'll skip this one. I'll go over it in class if you need me to. So on the next lesson I'll do the second page. Thank you for watching. Bye bye.